everyone, how are you all? My Panshi and welcome back to my YouTube channel. And in the previous session, in the lecture number 0, we learned about how the calculus is useful in the machine learning, and we learned some of the terms which we're gonna use in the future tutorials. Though the last session is very basic, and in today's lecture we will start basically the main calculus. We will learn about the functions family, domain and range, and how the geometry is used in calculus. So let's move forward without wasting any minutes. So why calculus is matters in the machine learning, as we understand how much small changes is happening over a time, we have to calculate it to reduce the error or to optimize the thing. In the last video, I shared one of your example, like the Sam Altman, the OpenAI founder, tell you like we are running out of cash and we have to save some money, so we have to reduce some data. So reducing the data is the only option when you find out which data is useful. So you optimize the data. It is used by the calculus and how the error is being reduced. For example, you are on a cliff of a big mountain. Like this is a big mountain, okay, and you are on this cliff. Now you have to move forward in a way that you don't fall down and you don't die. So this is you have to use calculus for that. Do you understand? Do you have to use calculus for that to find out which path you should take to which reduces the error and which makes you don't die, which makes you live longer. So this is the only one of another example that we gonna use to understand the calculus. One of the most amazing algorithm which is 100% based on calculus is gradient descent. Like this, we have a graph. Don't just get confused between what is global minima, local minima, and anything you are seeing on this graph, because once you start learning machine learning, you will this all makes sense to you. So just focusing on the learning concepts, okay. So we have to find a point. This is a point, like this is a point. We have to find a point to move a parameter in the direction that reduces the loss function, which reduces the error, which give us the more suitable outputs in our future projects. Okay, so we have to use calculus in that scenario. Gradient descent is one of the most amazing algorithms, and in this algorithm you will remember all the things we're gonna learn today. So let's move forward. Okay, what is a function? Function is a some set of a rule. Let's understand with another example. Function is demonstrated like this: f and x. This is input. You can put any value in it, like f, z, f, y. It's totally depending upon you. It's a variable. Okay, so you name it anything you want. Okay, so fx is kind of a famous in the textbook, so we use fx. Function is some set of a rule which give only one output, let's understand with another example. Fx, we have a x key value. We will put x key value like 1, 2, 3, and 4, and we have to find out x key value which is square. When we put x key value which is square, like x square, if we put fx this, we have a rule x2. For example, we have a rule this. Now we have to put a value 1 here, the output will be 1. We have to put 2 here. 2 square equals to 2 into 2, which is equals to 4. Now we have to put 3 here. 3 square equals to 3 into 3, which is equals to 9. Now we have to put 4 here, which is okay. Now you are understanding, making sense. Like we have a particularly a set of a rule which give a particularly single output. It is called function. So basically function is a rule that assign exactly one output to each input. I will share the material, like this material as well as, and this material is made by Claude. I waste a lot of good time making presentation. That's why I'm not consistent enough on YouTube. But now I find a way, and the smartest way to use AI. Okay, and I will share this material to you as well as. Okay, now the function and graph is this, like I will not confuse you, but when we are changing the value of a function, we are seeing different level of a graph. It is a shift on its location, it's a shift of its its uh, its size, it's a shift of its, okay, let's understand, it's shift of its height. So I will not confuse you between all of those things, but you can see when we are changing our data, when we are changing a particularly value, it will form a particularly parabolic shape. Whenever something is making this kind of shape, a parabolic shape, that means it is a function. It is one of the most important thing. A curve is a valid function if and only if every vertical line crosses it at least most once. If one of the vertical line crosses it once, that means it is a function, and it is mostly used by the parabolic shape. A circle failed this test. Two crossing a parabolic passes. If you see the graph which is in a parabolic shape, parabolic is basically these kind of thing. When you throw a ball, you throw a ball like this. When the rocket flies, it flies like this. This is a parabolic shape. Whenever in a graph you see a parabolic shape, which means it will form a function, but in the circle it is not a thing. Whenever you see a graph is forming a function, a graph is forming a circle, which means the data in it will not perform a function rule. Okay, understood? Now let's move forward. Okay, uh, these are the sum of the functions which we gonna use when you learn machine learning. You're gonna use the sigmoid function, softmax, and a different functions usage in your machine learning projects. So let's move forward because this is out of scope, so we will not discuss it. But domain and range is one of the most important topic, and it confused most of the students and aspiring machine learning engineers. So let's understand the domain. Domain is all valid input. So what is domain? Let's understand. Let's read out the definition. A domain is a set of all valid input, and the range is a set of all possible output. Now let's understand with the help of another example. Your age can never be negative. We all know age is never negative. Your age is never be negative. Your age can be 1, your age can be 2, your age equals to 3, but your age never be 0.1, minus 1, minus 3, and so on. So we have a particular set of rule that age is equals and greater than 0. So this is how the valid input, and we call this kind of condition domain. We call this kind of condition a domain. So you understand the domain. Domain is the valid input. Whatever the valid situation is, we called it as a domain. Age is a particularly the great example to understand domain. Let's move forward. Now what is range? Range is a set of all possible output. Like all the possible output, the range is a set of all possible output. Like what could be your age? Range is basically all possible output. Your range could be 0 to basically 100. Okay, the maximum human being level is 100. So the criteria between the range is 0 to 100. Okay, 0 to 100 is a range. So most important part is in domain and range is how you're gonna use the round bracket, the square bracket. Okay, this is called round brackets, and this is called square brackets. Okay, this is called round brackets and this is called square brackets. So for example, we use round bracket. For example, we for let's understand what is round. Let's understand round topic 1. For example, if we use 0 and 5, when you see such representation, it means we don't use 0 and 5, we will use any number between it. For example, 0.1, 0.2, and 4.9. So this is how it represented. For example, when we write 0 to 4, this is how it wrote, which means we have a number 0.1 to 3.9. We will everything it included excluded 0 and 5. This is how the round bracket work. Now in the square bracket, these are things is also included. For example, 0 and 5, which means include 0, 1, 2, 3, 4, 5. Anything between this. Also 0, 0.1, 2.3, 4.7 and 5. Anything between it. So in the square bracket we use these numbers too, but in the round bracket we use anything between it except this. We don't use that. Okay. So practice these are the things because the domain and range, these kind of a thing is kind of a important. What is a linear, quadratic, exponential, and logarithmic function? Let's understand each function because in the future we're gonna use all of these function mostly, and you're gonna see all of these kind of functions, all these kind of statement in the upcoming session as well as. There is a family of four building block you will ever encounter in the topic function or ever in the mathematics. First is a linear. First is a linear graph. For example, what is a linear? When a thing is constant. For example, we all know when the year pass by, the inflation will increase. The cost of living is increased with a constant rate. So this is called linear and it is y equals to mx plus b, where m equals to slope. Slope is this distance. Okay, and b is bias, like if there is a certain gap, if the graph started from here and then constant, then this is b. So linear equation is formed like mx plus b, which have two variable y and x. M and b will always be given to you and you will set m and b based on your information, based on your topic. So this is the linear constant rate of change. When there is a particularly constant rate of change, straight line, slope and things. In the machine learning, it is used in a linear regression, neural networks and etc. So quadratic equation, when you get the power of a 2 in any statement, then it is called quadratic equation. Then it's called quadratic equation or quadratic function. Parabolic shape, it is always form a parabolic shape, like a shape, this, like a U kind of a shape is parabolic shape. One minimum maximum rate of change is not constant. It grow with the x. It grow with the x. Like this is a particularly the best graph to understand how a particularly function is working. Linear is very straight because rate of change, the particularly things are changing over a time is a very constant and it's not changing extraordinary. So it's a linear. And then it is a quadratic which is change, which is depend upon x. If x change, then our quadratic equation graphs change. If the value one maximum minima, the value of any of the variable which means a and b is a variable here. So the value of a and b is changing, it's a rate of a time and it is not constant, then it's called quadratic. Now, exponential is known as extraordinary changing and massive changes in happening with very low amount of time. Explosive growth. It is known as exponent. Like you can see the exponent graph is like constant, constant, and then it suddenly grow. So it is exponential. Now, logarithmic. The inverse of exponential. The inverse of exponential is called log. Now you understand what is log. Log is the inverse of exponential. The massive growth and non-massive growth. Then is slow diametric. Grow fast at first, then suddenly something like our motivation. When we watch a motivational video, our motivation spike, and then after some time it slow down. So this is how the logarithmic functions work. Like first its growth is massive, and then it is slow and dramatically fall down. So defined by the positive of x. Okay, so these are the four most likely class, and this is the family. Like there are the four. We can just ignore the derivative because we haven't learned derivative as of now. So I will not confuse you with that. You can just understand linear. The rate of change is a constant. Grow faster than nothing because it's a constant. Quadratic, it is a faster than the linear and proportional to x. If x grow, then the quadratic graph will grow. Okay, then the particularly the different variable will grow. Exponential is like it is the fastest because we are talking about the exponential growth, the massive growth. So it will grow eventually, and logarithmic function is just opposite of exponential. So firstly, it's grow massively, and then it will slow down. So this is how, this is your check your understanding which function is growing the faster for large x. Basically the exponential. Now you have to find which of the graph is exponential. Okay, and then give me the solution in the comment check. I will connect, I will also share my file, so you can just stick on it and find it which one is better. Now coordinate geometry. Whatever I'm talking about, the x and y is a coordinate geometry. Quadratic geometry is one of my favorite topic. Whatever we do on this kind of a graph and we have to find the distance between point A and B, we have a particularly the formula which we're gonna learn in this, like a distance between the 2 point is measured by, let's understand, okay, where it is, okay. So let's understand x2 minus x1 ka square plus y2 minus y1 square. So we have given a 2.2 and 1 and 3 and 2. Let's understand 3 and 2. I have a bad handwriting, that's why I follow this profession. This is one of the reasons. Okay, then 1 and 2. Now 1 equals to x1, 2 equals to x2, 3 equals to y1 and 3 equals to y2. Now you have to just allot this thing and solve the whole equation. This is the most simplest thing. That's why I love coordinate geometry, to be honest, because that's too simple to understand. Now you have to follow the same example. It is very simple, it is very theoretical, it's not very hard to understand. Okay, scatter points in the coordinate geometry, each data is a feature 1 and feature 2. Every point is some sort of a data. We find the distance to classify, and the distance, finding the distance between the 2 point is very important when we solve the problems in the clustering. When you understand machine learning, there's an algorithm called clustering, and when you have to find the shortest distance between the two data set to make things more optimized. In that point of view, the distance and the coordinate geometry comes into the picture. Okay, so this is all for the today, and in the today's video we learn about the functions, what is function, the domain and range, what how the function is a some set of rules that work upon its representation, and then we learn about the four families of the function: linear, quadratic, exponential, and we learn the way how it is work on the graph. And then later on we learn about the coordinate geometry, how we can find the closest distance between the two articles, and how it will be useful in the machine learning tutorial. So that's all for the today. See you in the next session. Bye bye.